Number 3 here, you're going to find the area of the parallelogram. Let's remember the formula for the area of a parallelogram. It is defined as area is equal to base times height. This is referred as to the base right here. Then this is referred as to the height. Okay, so we know that the base is equal to 12. Do we know the height? No, the height is unknown here. The fact that the height is unknown here, we have to figure out a way to get it. Okay, so we have this triangle though. Okay, we have this triangle. The fact that we know this triangle, right, we can potentially solve for the height here. Okay, so if we draw that person here, we can set up our trig ratio, right? So we have here the hypotenuse, and we have h here as the opposite. So we can now see opposite and hypotenuse. That is sine. So we can say sine of 60 degrees is equal to the opposite over the hypotenuse. Okay, so sine of 60 is equal to the height, which is the opposite, over 20, which is the hypotenuse. Multiply 20 to both sides, because this is how we get this to cancel. Now we get h alone is equal to 20 times sine of 60 degrees. So here we can now get a height value. 20 times sine 20 sine 60. Okay, this gets me h is equal to the value of around 17.32. Okay, so h is equal to around 17.32. Okay, I did this whole thing here because I needed h. Now we could plug it into the area formula. Okay, 12 times 17.32. And now we can get the area is approximately 207.85 centimeters squared. All right. We only did the trig ratio here is to solve for that height. All right. Let's look at B here. All right. So for B here, again, we have to remember our formula for the area. Our area here is equal to the base times the height for any parallelogram. And I know that the base is this entire thing, which is also this entire thing here. That is the base. So we have base is equal to 23 meters. Now I want to see the height. The height is right here, but I don't know the height. However, I can grab this object here to get me the height. Okay, I see that small right triangle for the height. So here's the height that I want. If I draw that person right here at that 45 degrees, I could see a trig ratio because the height is the opposite. The 5 centimeters is the adjacent. So I can set up tangent. Tan of 45 degrees is equal to the opposite over adjacent. Once I write this down, I could plug in my formula. Tan of 45 is equal to h over 5. Multiply by 5 to both sides, so I can get rid of the divide by 5. I get h is equal to 5 times tan of 45. Now I plug that in. 5 tan of 45. I get 5. h is equal to 5. H is equal to 5. Now I can plug into my equation for the area. Base is 23, height is 5. So the answer is 115 meters squared. And C. Here we have C. Let's write down our formula. Our formula for area is equal to base times height. Oh, I have the base here, which is 21 feet. Do I have the height here? I do not have the height here, but I see a right triangle that I can grab. Okay. This right triangle, here's the height. I can't set up a trig ratio because I do not have an angle measurement, but I have two sides. So I can set up Pythagorean theorem. I can say 8 squared plus h squared, right? The two sides squared is equal to 17 squared. Okay. 8 squared is 64. H squared and 17 squared is 289. Okay. Minus 64 to both sides. H squared is equal to 289 minus 64. This is 225. Square root both sides. So to get rid of the square, h is equal to 15. Right? So now I can plug it in. I have base, I have height. So area equals to 21 times 15. Okay, area equals to 315 feet squared. All right, so there you go. That is how you find the area of a parallelogram.